Alright, so we are a couple of minutes early, but I just thought I'd start because I've got everything up already, ready to go. So unfortunately though, because of my crap camera setup right now, this is as close as it's going to get with the PCB, and this is what I've got with my PC view, so I'm going to swap between the two as I flick between the schematic and the actual PCB itself. So I've already put together the 5-volt power rail and the 3.3-volt power rail. I then unfortunately decided to, well, not decided to, but I fried my tin C4. In fact, it's been a pretty tragic morning, because not only have I fried this tin C4, but I have also fried this tin C4, and I have also fried my power supply, all in the space of one morning, trying to put this together. So that was a bit disappointing, and it turned out the main problem behind that was that I was powering, well, for the Tinsies dying, was that I was powering them through this 3.3-volt chip, and it turns out it's not exactly 100% stable. And if I go to my PC view, I think I can bring this up. Tinsi4 schematics, let me see if I can find it. Yes, okay, so if I go to PC view, so essentially the Tinsi4, if I scroll down to find that, has two power rails you can supply with the pins. You can supply the V-in, which is 5 volts, or you could supply a 3.3 volt rail to it. The 3.3 volt rail is completely unmanaged, and it just goes directly to the processor, whereas the 5 volt rail goes through some extra stuff to manage it and bring it down to 3.3 volts and make it a bit more stable. That was my mistake, and it seems that my linear regulator on here doesn't provide a perfect voltage, so that it completely fried both my Tinsies when I put them on. So I fixed that with this wire here. So essentially what I'm planning to do, so I've ordered a new Tinsi4, and my plan is to bend the 3.3 volt pin out of the way for now and run a wire from the 5 volt regulator down to the V-in pin, which is this one here. So hopefully tomorrow I can test that, because I've ordered a new Tinsi and a new power supply to test it with, but as I said, I'm going to go ahead with the plan now tonight and actually start assembling it. I mean, I've got my multimeter so that I can at least make sure things kind of work, but can't really check if it will actually work on the Tinsi. And yeah, sorry if it's a bit blurred, but this is just my crap camera setup I have currently. I'm not using a microscope or anything. I've literally just mounted a phone camera above my monitor, pointing down and zoomed into the PCB here. So I can bring that out the way, and let's see where to start with first. I'm thinking, let me get the voltage sense system out the way. So if I go ahead to here, oh, not this one, if I go to this one, there we go, I can have a look at my schematic I built, and I can have a look at what's on here. So if I go find this in my parts tray, one sec, I've got my parts tray to the side of where I'm all streaming, so I need to go ahead and rummage through a few parts. One second. Who are you? You are... Supply part number is C3361. So I need to find this somewhere in here. Okay, there's one, and I also need a 2.2 kilo ohm resistor and a 10 kilo ohm resistor. Which one's the 2.2k? 2.2k is... You can't see this because it's off the screen. C204, so let me see if I can find that. I've also found my 10k resistor. Is this the right 10k resistor? Because I think I might have just found that one as well. C104. Nope, this is the wrong 10k resistor. That's... But if you guys want to just ask anything in chat throughout the stream, go ahead. That's the wrong component. I should really organize these. 10 kilo ohm. Which one are you? C1. Okay, so that's the right one for this. And I lastly need to check out the 2.2 kilo ohm resistor. Who are you? C204. C204, where are you? C20475. Okay, I've got them now. Right, so let's begin. So R. Okay, so here are the parts I've got. So I've got one set here, I've got one here, and I've got another one here. So I only need one of these little tiny things over here. Let me go get that out real quick and we can solder that one in. Jeez, this is tiny. I did not prepare for soldering something this tiny. Christ. Okay, soldering iron is nice and hot, so I'll get a bit of flux on here for D7. And yes, I am using a toothpick. I mean, it seems to work really well. Okay, I think that should do. Let me go ahead and start soldering this. Problem is, the slightest movement moves this thing quite considerably, unfortunately. Okay. Hold this guy, get down. Okay, that's in now. So now I just have to finish up the other two legs. Cool, so that's in. Now to find 10 kilo ohm. Which one does 10 kilo ohm belong to? That's R14, so I need to solder R14 in. So we can bring that out. Come on, out you come. This resistor is being very stubborn. There we go. So this is R14. So R14. Cool, one leg's in. Let's do the other leg. Actually, these resistors are really surprisingly easy to solder. Okay, and finally, which one are you? You have a 2.2 kilogram, so you're R15. Also, if you guys are wondering why I said the stream would originally be on Friday and delayed it, because FedEx didn't deliver my PCBs on time. That's the first time they failed me. They're normally on time. Cool, that's in. Next one. Okay, so with voltage sense being in place, I think I should be able to power this up with my battery charger and hopefully get a reading out of this pin, which is somewhere in the neighborhood of safe voltage for the Tinsy, so I'll try that. Hook this one up. Where's my other cable? Put the other one up. Okay, now I need to find my multimeter and do voltage DC. And if I go this pin here to ground, I seem to get 0. Is the power supply even on, or do I need to? Oh, I think it's because I need to connect a load to it for it to actually activate the power supply. Double check that. Oh no, it's because I've got my power supply in the wrong, or not power supply, my multimeter in the wrong port. One sec. Okay, let's try it now. So ground. Still nothing. Why doesn't this work? So I'm getting 0 volts on my power supply. That would be a problem. I think I actually do need to connect a load for it to register and therefore draw power. 1 second. Up to there. And put my broken Tinsy on. That should at least draw some power. Okay. Hey, we have 2.4. That's great. Okay, this works. And it's safe. Okay, let's continue assembly. Okay, next on the to-do list, I reckon, oh actually we're going to change to just these EDA, would be these guys over here, which are the ATF temp N3 and N2 RPM sensors for the transmission. So let me go ahead and find those components again, and then we shall start soldering those. So, resistors, resistors, resistors. 1 kilo ohm. Hey, who are you? That'd be this one. C49. Yep. Okay, so I've got that. And 1.8 kilo ohm. for R12. Ohm, wrong one, wrong one. Actually, this can go on the floor because I'm never going to use that in this design. That's... Nope. 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 1.8 kilo ohm. Here we go, found them. Right. So, let's start with the smaller ones first, because these are going to be a right pain to solder. And I'll just go to camera for this, since it's going to be fairly basic for me to solder these. So you can see how tiny these are here. They're stupidly tiny. Go ahead and apply some flux to the RPM sensors. Take my tweezers and peel back the foil on these just enough so I can unveil the 3 of them. One, two, three. Oh my god, these are so tiny. Like, they literally looks like flakes of dust. Okay, put you there. Let's go ahead and solder. Where's my 0.3mm solder? I should probably move this one slightly further. There we go. One down, next to go. Ah, it's got stuck on the tweezers. One sec. There you go, don't get stuck on there. I should put them all in the rough place so that they don't go moving, because the flux is sticking them to the PCB. Okay, let's go ahead and put those on. Yeah, I'm sorry again, the quality of the camera is so crap, but this is all I could do. Okay, so I think those resistors are all in place. Let's just quickly double check that with my multimeter, make sure the resistance is okay between those wires now. So switch you to resistance. I should see 1.8k on these. If I go to 2000, so that should be 1800. So if I go here to here, okay. Actually, why are these only registering as 1000? Oh, I put the wrong ones in. That's great. No, no, I haven't put the wrong ones in. These are meant to be 1000. Ugh. Cool, okay. I've tested those, they all work, so let's put the 1.8K ones in now. Cool, so 1.8 kilo ohm. Gonna need 3 of these. Cool. Right, so go ahead and put flux on. Also, by the way, with regards to the schematic, I'm not going to make it public just yet until I've done enough testing to know that everything is safe. Once I've deemed everything is safe and I've got a final version of the PCB I want to release, then I will make the schematic public. Just purely because I don't want you guys to, you know, accidentally, well, for someone to make a wrong version of the PCB. I'm also considering selling pre-built modules. I mean, let me know what you feel about that idea. Because in that way you basically just buy the module from me. I make a tiny bit of money from manufacturing these and for the time spent developing it. And in return you guys just get a transmission you guys can play with all you want. Cool, so I should see 1 kilo ohm from this point here. I'll use it my speed. I should see 1 kilo ohm from this point here to this point down here. Let's quickly test those. Sorry, 1.8 kilo ohms. Let's make sure that's all okay. So ATF line to this one. Yep. 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 Great. Works. Okay, so now I'm thinking let's just quickly clean up the PCB around here, make it a tiny bit cleaner. I've got some alcohol here. You can generously lava all over this. Cool, that'll do. And wipe away all that unneeded flux. Cool. Now you can't see. I mean, I'll post a picture of this on my Twitter if you guys haven't already seen my Twitter, but I'll post a picture on it there. Next, I'm thinking I want to get these capacitors up here done. So if we go to Easy EDA, go to solenoid control. Come on, load it up. So that should be C7. So everything here is the same. So 22 nanofarad capacitor. is what's needed. I go back to my parts bin down here and try finding the 22 nanofarad capacitors. Okay, that's 100 nanofarad, not the right one. Let me find, where's my 22 nanofarad ones? Here we are, 22 nanofarad capacitors. So I'm going to need 1, 2, 3, 4, 5, 6, because one for each solenoid of the gearbox, essentially. Oh bloody hell, these are even smaller than the other things I've soldered. One, 2, 3, 4, 5, 6. Dump them here. 6. Cool. Fold you back up, won't be needing this again, so that can go in the bin. Well, not in the bin, sorry, the my parts bin of finished parts that I don't need for the rest of the stream. Oop. So these are going to be very difficult because I'll be doing it at an angle. Just quickly brush these all to one part of my board here on top of this ground pin. I think it's a nice place. Okay, some flux. So if I'm being quiet right now, I'm trying to concentrate on placing these perfectly in place without disturbing them. Okay, right. Soldering. I think I'll start on the top sides of each of these. Oh, that wasn't good. I just dropped something. Here we go. Oh, we got 10 people online. Welcome aboard, everyone. We're slowly gaining people. I like it. Gonna be honest and say doing this without a microscope is actually painful. Cool, let's move these all into position now. Cool, so I think that's good, that's good. Okay, this is the last one we've got left then. That's good, that's good, that's good, that's good. Right, solder the tail ends, and then we're done with these guys. Ouch. And then finish this one off as well. So I think that should work. I actually have no clue if it will work or not, because I don't have the tools to test the capacitor, unfortunately. But I think that's a good job, or a good shot at it at least. Remember as well, this is like a revision 1 PCB, so there's still going to be probably multiple attempts at this in future as my electrical skills get better. Right, CAN bus now. Let's get out the way. Also did realise you just could see back of my head there. Yeah, this is how close it is to my desk. So, CAN bus, let's go to my PC view, have a look at CAN bus, which is somewhere up here. So you are, who are you? 491150. Let's see if I can find you somewhere. Ah, however, I will need this as the CAN transceiver. $120 ohms. I'm going to keep the 120 ohm resistor out for now, so I'm going to keep R16 out just in case my car can live without it, because I don't know what the side effects would be of having too many 120 ohm resistors against canning cans high and low. So for now I just need that and C15, which is a 100 nanofarad capacitor. Let's see if I can find him somewhere. Here we are. Alright, let's do the CAN transceiver first. No, actually, let's do the capacitor first. That makes more sense. Jeez, these capacitors are tiny again. Oh well. Oh god, you know what I've just realised, okay? I've realised you guys are trying to talk to me, but I thought something was wrong because I've got no live chat view. For some reason my live chat's just completely empty. That's really strange. Okay, but I can't do anything because if I close this, then I lose live chat. Okay, tell you what I'll do. I'll just open it up on YouTube so I can quickly read through messages that you guys have already sent. Whoops. Do you want solder paste? No, I don't have solder paste and hot air gun, by the way. And yes, Ian, I know that I need to add the protection diode at some point, so that will be something else for Rev 2. So again, we'll fix this here. Sorry about the fact that I haven't been answering to chat. Oh. Hey, KDizzy07. Just soldering a custom ECU for a car. Or manufacturing it, if you will. That is what the YouTube live algorithm has bestowed upon you today. So let's put C15 here. Open pilot. Ah, now you see KDizzy. I'm gonna call you back. KDizzy07. Yes, I have heard of autopilot, and yes, that is something I'm thinking of eventually adding to my 203, Mercedes 203, which is like from 2006. That's gonna be a very big project, but it's something I could theoretically do. It just requires a lot of retrofitting, as well as also possibly making my car a hybrid, because there is plenty of room in the boot to store a battery pack of a very decent size in my car. Okay, now I need to bring the CAN transceiver out, which is the star of the show for this bit, and put them in place. One of the few CAN transceivers you can get these days because of a silicon shortage, which is unfortunate. Everything seems to be so rare nowadays. Cool. Put some nice amount of flux here. Cool, now which way do you go according to the schematic? You go... Ah, this is actually a good point. This chip doesn't have any form of marking on it. Bring it up to the camera, let's see if the camera can see. I doubt it can. Yeah, there is no way in hell you guys can see. Wait one sec, let me see if I can turn it to focus. Nope, it's not going to focus. There is no marking on this, so let's quickly Google this guy and it should tell me. Is the CAN transceiver fault tolerant? Yes. Yes it is, I made sure it is. So let me quickly go to the data sheet here. Okay, so if I go to PC only, this is the CAN transceiver we're using. Go down. Okay, I want to see where's the package pictures. Package pictures, anyone? Package pictures? No. Well, this is useful. So you've given me a CAN transceiver with no markings on it. Oh, this is frustrating. Let's see if I can Google the polarity of this. Let's quickly do that off camera. Yeah, I've been watching Rich Rebuilds do this as well, Dizzy. The thing with me, right, so I want to prove a point, which is that if car manufacturers wanted to be so eco-friendly, they'll work more about converting older existing cars which are on the road into hybrids rather than making new hybrids or electric cars, because the CO2 emissions involved in making a brand new car from scratch versus updating an older car is way worse. That's my point I want to make, and yes, it will be an absolutely huge undertaking. But I'm up for a challenge. If you see some of the other stuff I've done on this channel, I've done quite a bit of really fancy stuff with my car, so it's kind of up my alley. And my car doesn't seem to mind, which is the main thing. Oh, there is a divot! Okay, there is a divot. It's just so hard to see because of the lighting I've currently got in my setup. So, CAN TX is here. There we go. Yeah, I know it says bottom left, but the problem was there was no marking for me to establish which bit's the bottom left on the chip, because you could flip it around 180 degrees and the bottom left would now be the left top right. But yeah, I fixed that now. I've worked out which pin is which. Perfect. Right, let's do the other pins. So for this, I should just be able to load up my soldering iron with solder and just scrape it across all the pins. I mean, we can wick up the excess. I think that will work best for this. Get some thicker solder out. Cool, and now just to go over it again so that I can get rid of all the excess. Okay. Right, I think that's good. Let's clean up the CAN bus area. Give that a very nice clean. CAN bus is literally like the most important bit of this. Oh, and the solenoid drivers. Because if CAN bus doesn't work, essentially the rest of the car won't be very happy. Which is also the reason why there isn't really an existing transmission controller for the 722.6 series for the newer Mercs. Like for the 210, W210 there is, but not for the W203 or anything newer than that. Because it's all CAN bus based, and I mean, with the stuff I've done with my car, I now know how my CAN network works in the car. But it's kind of unknown knowledge still. Right, I think it's now time for the big boys. Let's get them in place. Now again, due to the silicon shortage, I had to settle for TLE6220GP solenoid drivers, hence the reason why there's all this crap at the bottom of the board here for converting between 5 volts, which is what these torque at, and 3.3 volts, which is what this torques at. I should also note now that these chips are ludicrously expensive. I think I paid, I kid you not, £15 for one. So in total, I've spent about £60 on 4 chips. But I need 2 for this. If you guys want to donate, I could theoretically leave my PayPal address or Patreon. I mean, what does the chat think? Do you guys want to donate? Or do you guys not mind not donating? I mean, of course you don't mind not donating. It's friend-free, isn't it? God, what am I saying? Actually, let's quickly put in C6 and C5 before I do the solenoid drivers. So, C6 and C5, according to the schematics, are 100 nanofarad. Let's find those. I just had them in here, I think. Here they are. Okay, I believe that's all I need for these capacitors, so they can disappear now. I don't need them anymore. And yeah, I really don't want to break these. If I break them, I actually think I'm going to cry. Like, genuinely, the mistakes I've made making this PCB have made it so expensive to manufacture. Like, I think this one board here is probably now worth about £300. In parts and mistakes for getting different boards manufactured as well. Because I made so many mistakes manufacturing this. Okay, that's those in. Now for the big boys. Oh, I'm gonna hate this if I mess up. Actually, let's do them one at a time. They're so big, I think it's best to do them one at a time. Don't mess this up, Ashgon. Do not mess this up. I'm actually scared I'm gonna break this. Just need to get one leg done, then I can feel a bit more confident in myself. Okay. a little this way. There we go. Okay, do the opposite pin. Okay, that's now secure. So now to do the same scraping across with solder technique. And then we have to do the ground pins on either side of this. Where'd my big solder go? There it is. Okay, that's way too much solder, so let me go over this now, this row with my iron again. Actually, I'll put some flux on again. Oh, now that's perfect. I'm happy with that. Right, now for the bottom side. Okay, I think... Okay, for some reason there's one pin here which isn't soldering properly. Let me just quickly go over that again. There we go. Okay, so now just to very quickly double check that we don't accidentally short any of these pins out, I'm just going to quickly do a continuity test between every pair pin. Just to make sure I haven't bridged something. Because that'd be a real nightmare if I did. Continuity. Okay, that row's fine. Brilliant, they're all fine. So, now all that's left is to solder the ground tabs, which also act like a heatsink, so this is going to need big solder, not baby solder. Okay, next side. Okay, now let's do the second IC. Hey Scarborough. Yeah, I'm doing fine. Okay, that'll do. Where'd my tweezers go? Ah, here we go. Cool, there we go. Tiny bit more solder to this. Okay, I think that's done. Let's just do a quick continuity test. Oh wait, that's actually a bridged pin here. There we go. I mean, I'll just quickly do the ground tabs again. We are looking good. Okay, bit more flux because I see some black bits, so I just want to clean them up. Perfect. Okay, now to solder the side joints. Actually, I might do this with a different tip later, because I think they need a different tip. So let's tidy this up. Actually, let's... yeah, we'll do these first. Which is like the last bit of this. So, alcohol comes out. By the way, guys, question. How do you normally remove flux from PCBs? Am I doing it the right way with like a bit of alcohol? Or do you guys have a better way of doing it? One sec, I have a microfiber cloth in here. I think would work better for just finishing this off. Yes, I do. Okay, so finally we got these logic shifters, so I'm going to actually move the whole PCB so that it's a bit more centered on those now that we've finished the rest of the PCB. And there should work fine. So, these are going to be the worst, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them. I have to say, I'm actually quite impressed with my soldering, considering this is the first time. Clean the parts with a cotton swab. KDC, no, you're wrong. Name Ashkan actually comes from Iran. My father is from Iran, so. And actually, yes, you might be right about cotton buds. I've got one here. Let's just quickly try that. That works quite well, actually. Okay, right, let's start with all of the Q elements, which I believe are NPN transistors. Let's see if we can find them in here. How many people do we have watching right now? Let me quickly swatch over to here. 13 people. Oh, 8 now. Okay. NPM BSS138, I believe, is what these are. Let's just double check. Make sure I got that right. BSS138, yes. So, I'm going to take these out one at a time because I don't want to accidentally lose them. These are actually bigger than... Yeah, they're slightly bigger. So, 1, 2, 3, 4. Let's do 4 first. Okay. So I'm actually going to do this time is work a bit differently and pre-solder each one of the front legs of these. Also, I'm going to quickly flip the board round so I've got a better view. So it's north to south rather than east to west. This makes it a bit easier for me to work on. Okay. That's the rear legs of these. Cool, I think that should be okay. Right, let's do these guys now. So, I believe we have two different types of resistors on here. So we have a 10... Oh no, they're all the same, they're all 10k. Okay, that's not a problem then. Let me go find them. 10k, here we are. Oh my god, these are tiny. Yep, okay. Look at this nice big roll. So I need 1, 2, 3, 4, 5, 6, 7, 8 of them. Let's see if I can even open this. One sec. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Oh, you'll come. Okay, again, let's pre-solder all of the joints. Oh Jesus Christ, I just breathed too hard. Oh no, one of them's gone missing. I cannot believe how ridiculously tiny they make some components. To be fair, this is my fault for choosing components which are so ridiculously small for hand soldering, but you know what? As long as they do the job, I don't care. Very quick breather. So I can just relax my head or something. Because my neck does hurt after bending down for that long, just looking at a PCB like that. Okay, back to it then. I'm just going to reposition some of the resistors that have kind of like moved slightly. No, I'm never using 0201 0402. Thank you very much. Okay. Just gonna get a tiny bit of flux out and just finish up all the joints here, make them all look very pretty. Okay, right, thank God. We survived with the first row. We've only got the second and third row to do. I think now's a good time, Benevolent, to power it up and see if it just blows up or something. I mean, I have faith in it, but, like... Don't know if this will actually work. Okay, right, let me quickly plug the power supply and do some tests. Let's see what voltages we're getting. So I have confidence when tomorrow I actually plug my Tinsy into this, it just won't blow up. That'd be a real nightmare. Also, I'd be curious to see what amperage this is drawing, so let me actually connect my amp meter up to it. Where is my multimeter? There it is. So go to the 10 amp setting. So negative goes to there, positive goes to less than 1 amp. See what happens when I plug Tinsy in. Okay, that's good. So we don't have a short circuit so far. Plug this back in. And then let's do some quick testing, make sure we've got the right voltages. So, ground point, I will use this as my ground point, and now I can just prod. So VDC, make sure I've got 5 volts coming to the CAN bus chip so that I know that that's going to work. Huh. We have 7 volts going to CAN bus chip. Why is that? That should be 3.3 volts. Why is it registering 7 volts? So I seem to be getting 7.6 volts on the output of my 3.3 volt system. That's not right at all. What's going on? Could I have a short somewhere that I haven't caught yet? Yeah, I know, Ian. I know that's a 3.3 volt chip, but I'm really confused as to why I'm seeing 7 volts on it. I mean, undoubtedly I've probably killed it, but luckily I haven't had my Tinsy plugged in over here. Yeah, but Tinsy's already dead. I was just using it as a dead load. It's already dead. What voltage do I have going to my solenoid drivers? That's an important question. I should have 5 volts going to this. VS is the 4th pin. Okay, so I have 5 volts going to the solenoid drivers. So I know that works. Yeah. I have 5 volts coming into these. Yeah, 5.6 volts. So I seem to have 5.6 volts going into parts which are designed for 3 volts. That might be our problem. Okay, let me take these 4 components off the board and see if things go back to normal. If it is, then we know we've screwed up somewhere there. Let's quickly do that. Oh my god, I forgot how much of a pain it is to remove something from a PCB. No, I know the voltage regulator was working, because just a few minutes ago that was reading 3.3 volts. How do I take this off? Where's my solder wick? Here it is. Oh no. I've just ripped the pads off the PCB. Great. Okay, well, it's still salvageable, I think. Okay, my correction. It's not the pads that come with the PCB. Okay, that's good. Let's quickly test now without that one there, see if that makes a difference. Okay, so I got 5 volts here, 5 volts. 7.6 volts. Okay, so that's not helped. What's the voltage across the capacitor for the CAN chip? I can check. .66. Which is strange though, because you would have thought that it would. But if it was this as bad, you wouldn't be seeing more than this one. More than the 5-volt regulator's output voltage. Very bizarre. I'm still seeing. What am I seeing? Yeah, 7.6 on the input. Why is it doing that? Actually, one sec. I'm gonna go and get myself a hot air gun from the garage. I'll be back in about 1 minute or so, and then that way I can lift these 3 off here without destroying the PCB like I've done with this one. I say destroy it, nearly destroyed it. So I'll just leave the music on. I'll be back in a second. Okay, I'm back. So, what I'm going to do is I'm going to remove all this. I'm going to make some room. So I can put a pad and a piece of aluminium foil here to stop the heat from going to my desk. So just for under where I'm really going to be sort of heating. Just want this area here to be protected. Okay, let's go get the hot air gun and begin releasing some hot air. Apologies about the noise. Okay. Just need to find somewhere to put this without melting my desk. Okay, I think this should work. Yeah, there we go. So, without these three components now in, let's test that again. Okay, where is my multimeter? Where's my multimeter gone? Ah, there it is. So, across the CAN chip, I am now seeing ground there. 3 volts. I kid you not, I'm now only seeing 3 volts across that CAN chip. Let's see if we can see that. So if I go ahead and put myself on the 3.3 volt pin, it now says 3 volts. It doesn't say 7 volts. So, where do we think the problem might be, guys? Because I don't understand where the problem might be. The reason why I say that is because if I go to PC only, I am using these guys here. And of which, if I go to... let's see if I can find it. Yes, here we go. SparkFun have a bidirectional voltage converter, which is literally the same schematic. So SparkFun have this thing here, right? Which is quite literally the same thing that I have. If I go ahead and see if I can find the documentation for it and go to the schematics, here, it is literally identical, each one of these modules, to this module over here. So LV is 3.3, HV is 5.5. I don't understand why it's not working. Do you guys have any ideas? I'm actually confused as to why this is happening. Okay, let's just do a sanity check and make sure that everything here is perfect. So I should have 10k resistors in here. Let's quickly check that. These should all be 10k. Yeah, they're 10k. Okay. What's the voltage coming off the solenoid driver? Which pin do you want? Because the voltage coming off the solenoid driver here should be 5 volts, which... Oh, should get my multimeter at this right setting. Which it is. So that's correct. Something wrong with the little BS138 modules, unless I've got the wrong part, which seems impossible considering I ordered it from not Easy ADI. Where did I order it from? LCSC. So it should be the same. Yep, BSS138. Huh. It's the same part. Do you have the logic converter the correct way round? Yes, I'm just following the schematics that SparkFun have, and then they tell you how to hook this up. So this is correct. So let's see if I can zoom in on this one. Here you go, so you got HV1, HV2, ground, HV3, HV4 coming in from high voltage, and low voltage is LV1, LV2, low voltage reference, ground, LV3, LV4. And, I mean, ground doesn't matter for this because both sides are sharing the same ground on my PCB, like they all share the same common ground. But over here, so you've got, for instance, high voltage channel 2 coming in, with a 10k resistor going to high voltage reference, and low voltage 2 going in to a 10k resistor to L voltage, low voltage reference. With this BS138 in the module, with the middle pin sitting beyond the 10k resistor, which is what I've done here. So I genuinely don't understand why this isn't working. Remove the pull-up. Which pins pull up? Let's have a look here. Which pin are you referring to? Actually, I'll quickly move that out of the way. There we go. Ah, pull-ups are the resistors 5V and 3.3. Ah, okay. So you want me to remove the one on the 5 volt channel. See, I don't think that would work, because the whole point of this is it's bidirectional, so I can send a 3.3 volt signal down from the TINC, and that gets sent to the 5 volt rail on the solenoids. But the thing is, though, the pins on the solenoid drivers are all 5 volts. Like, I just checked them. There's nothing wrong with them. There's nothing wrong with these. That's all correct. And I'll do it again. I'll just check every single pin's reference voltage. See if I can find one pin which says 7 volts. Four point eight, 4.8, 4.8, 4.8. Is the pinout of the BAS 138 correct? I am literally using what SparkFun have provided, so I assume that's a yes. So if you look at their pinout here, well, this is my pinout, and then compare that to... So you've got this little arrow coming from the right side, which is from VIN. Oh, have I mixed these two sides round? 1 second, boss. No, I haven't, because the S stands for solenoid, so this goes to the solenoid controller. So this is the high side, this is the low side. Okay, that's correct. Just had a brief panic attack there, thinking about that. And then if you see on these ones, they again have the low voltage side coming in with the gate. I think that's the gate pin, the middle one. They have the low side there, low voltage coming into the gate, which is what I have over here. Reset 2 comes into the gate, and reset 2S comes in this way. Let's quickly double check that. So reset 2S. So reset 2S is this pen here, which goes to reset on TLE6220P. So I want to see what happens if I just float one of these BS138 on a PCB. Will it then suddenly jump the voltage to 7, just like by having one roughly sitting here? I'm just going to roughly plop you on there so that you can make some kind of electrical contact. Okay, that'll do. Yes, LV is source. LV is source for the low voltage side. Yeah, so LV is reference low voltage, HV is reference high voltage. Going back here, VIN 3.3, which is my reference low voltage, comes in this side. VIN 5.0, which is reference 5 voltage, comes in this side. Okay, so that works. Yes, middle pin of mass 3 is drain, which should be always be 3.3. Yes, it is. I can check on all of them. Oh, it's 5. Why is that? So why have they hooked it up like this then? I don't understand why they've done that. So in this case, drain goes to low voltage. Oh wait, which one's the drain? Let me quickly double check. BS138. Just so I know I'm not being stupid. Datasheet, BS138. Yeah, so drain is... Oh, okay, wait a minute, I've got it the wrong way. Yeah, so drain is the top pin. So in this case, they've got drain going to high voltage reference. Yeah, drain goes to high voltage reference. Which it does. I've got 5 volts on all of these. Well, maybe I should have less. I mean, when I say 5 volts, I'm rounding. If I actually go to it, it says 4.83. I mean, if I go to the V-in source of my... Okay, so I'm getting 4.83... Oh wait, actually, I'll quickly show you this. Cam only. So here, on these pins here, which is the drain, I'm getting 4.83 volts. And then if I go to my voltage regulator 5 volt pin out, I'm getting 4.9. Let me solder one of these chips back in and just see what happens. And maybe we can do some more debugging. Okay, I think that should prove a point, I think. Just soldering that one pin in should allow it to hit the other pins. What voltage are you getting the other side of the resistor? Let me check that in a sec. Actually, that's a good point. We could be getting a dead short across any one of these, and that could be causing the whole ordeal. So let's just go to continuity test and just very quickly check each pair. You're okay, you're okay. You're okay. You're okay. You're okay. You're okay. You're okay. And you're okay. Let's quickly double check that with resistance, so if I can say that they're each saying 10k. 10.05. 9.37. 10.01. 9.22. 9.99. 8.84. That's interesting. 10.03. 9.4. I mean, do you reckon it's the fact that these are slightly out of calibrated resistors could be causing it? If I go back to VDC. Need to find it. Voltage DC, there we go. And quickly pull again, so... ground. Would help if I'm connected. Okay, so I'm still getting 3 volts with the drain plugged in. Let's do the other 2 pins. Okay, I've sunk those 2 in. Oh, okay. It now seems to work. We now have 3 volts. Maybe it's just a bad chip, or maybe there's a issue around here with the PCB, because this did look indented. I might just be using a bad PCB. So that's good. That means the circuitry works, which is a huge relief. Okay, let's try putting a second one in, back in and seeing what happens. So I know this one was a bit delicate, so I have to be careful with this one, but let's try putting it back in. Okay, second one in. Let's see now. So ground, test the CAN transceiver. I'm getting 3.2 volts at the CAN transceiver now. So I'm basically using the CAN transceiver because I know if that goes bad to 7 volts, then we know that something's wrong again. Okay, so it still seems to be okay. Let's put the third one in. And if it's the PCB here, I'm in for a bad time because we have to desolder everything and put it onto the other PCB, which won't be fun. But hey, that's kind of good news, because it means I haven't screwed something up in my circuit design. I'm feeling a bit more hopeful than I was about 5 minutes ago. Add a tiny bit more solder to these pins. Actually, let's quickly see if there's a dead... No, a dead short would have shown up by now, so it wouldn't be a dead short. Where is my NPN transistor? Where is my BS series gone? They're somewhere on my desk. And now I can't find them. Ah, here they are. Maybe I just got a bad one. That's what I'm gonna hope. Here's 2 more. Okay, so now we do number 3. Okay, that's all in. Let's try it now. Still getting 3 volts. Good, good. Okay, I'm definitely feeling a lot better now. Okay, let's try the last dodgy one here, which I have a feeling is probably the bad one. Considering it smelled like burning when I was putting it on, I have no clue if it was just kind of dodgy or if it was like on its way out. Put a little bit more solder on that one. Oh! There we go. Okay, if now we see 8 volts, we know that something's wrong with the PCB. Oh, this is interesting. We have 3.2 volts. Okay, so they all work now. That's brilliant. Let's clean up this row then. Let's quickly clean them up. Needs to be cleaned. I like clean. Then we can move on to row number 2. And this time we'll check after soldering every single one, just to be sure that we haven't got another dodgy one somewhere. Okay, just do another test if that cleaned. Maybe it's short crossed the MOSFET. Yeah, that's what I'm thinking, because one of this last one here smelt slightly of burning when I put it on, so I don't know if I might have killed it. Still saying 3.2 across the CAD transceiver. Okay, let's move on to row number 2 now. Oh, I'm excited. It means we don't have to redesign the whole circuitry because of a stupid error. Actually, we'll just quickly test the continuity as Ian has suggested. On the left of the 3 pins. Just make sure I've got continuity to the Tinsy. Just remember which one this goes to. Yep. Yep. Just quickly make sure the voltage across these pins are okay. Okay, let's do row number 2 now. I'm happy to continue. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. Also, you know, I'm going to call these now the forbidden something. I don't quite know what forbidden this should be. I'm thinking forbidden chips would be like, look, this is 10 of them. They're tiny. Okay, that should be enough flux. Oh, I realise I'm moving this. There we go. Also, by the way, I should probably mention my last exam for university is on Friday, and then after that, it's full-time fun. So I'll be working on this a lot more, which is why I want the assembly finished this week, so that come this weekend / next week, I can really start making progress on it in the car. Do you get OCD with number on resistors? No, I don't. I literally do not care because I'm never going to see this. It's going to be inside... Where is it? I can't find the box, but it'll be inside the box in my car, so I couldn't really care less. I mean, on saying that, if I want to make a demo unit for, like, showcasing the board, yes, I will be really OCD. In fact, I'll make the PCB in blue or black as well for that. Also, I should probably mention one of my plans for this that I've started work on already is a Keyword Protocol 2000 emulator for this device. And if you don't know what that is, basically it's a diagnostic protocol Daimler use to talk to the transmission. And because of my work with Open Vehicle Diag, I know exactly what commands should be sent to this and how the TCM should respond with Mercedes' own software. Meaning that I can basically have you diagnose this in Mercedes' own software. However, I will add additional functionality to my own diagnostic program to say, like, so that's one of the plans for this as well. There's so many plans for this, man. And also one thing as well that I'm thinking of doing is porting the code base. So essentially EGS53, which is the 722.6 gearbox controller for the 204 series of Mercedes, so that's like 2008 to 2012. They are identical to the EGS52 module which I'm building, except for the CAN communication matrix is slightly different for the newer car. So I'm making everything modular so that you can just basically hot swap which modules you want. So I can say, for instance, I want the W204 CAN matrix model, but I want, say, for instance, the shifting profile from an AMG vehicle. Or, for instance, you can then ask it to also say, I want it to work with Daimler software to pretend it's a 203 being diagnosed. There are all kinds of weird, wacky stuff that you can do with this. So yeah, that's the plan. Do you want me to post you a value paste auto Tincy 4 ECU? Value pasta. Can you send me a link to this? You have me on Twitter, Ian. You can just DM me a link. I want to see this. broke that resistor. Time for another one. There you go. How long has this stream been going on for? Oh, 2 hours nearly, wow. I mean, we're nearly at the end. Currently have 9 people watching, decent. Okay, I'm just checking out your link now, Ian. Ah, I've seen this. Ages ago, though, I just didn't recognise the name. No. I don't want that. But no, it's a nice design, I like it. But this is the whole idea of this particular module here, is for it to, well, basically be an incognito replacement with just so many benefits, but so that you can take your car to a Daimler dealer and they'll be like, yeah, it's a stock module. Which is why the PCB is designed in such a certain way, so that the stock, let's see if we can find it, here you go. The stock TCM housing can just plonk itself on top and slide itself in the case, and then Mercedes will be none the wiser that I'm running something which outperforms their transmission modules by at least a factor of 1,000, which is always fun. So I need 1, 2, 3, 4, 5. These little boys. There we go. Right, now's a good time to double check that everything's working okay before I begin. Can you add some stop any shots? Okay, where's my multimeter? Let's make sure this is all okay prior to soldering, so that in case something goes wrong we know it's because of what we're currently soldering. Three volts, 3 volts, 4.8. What's R6 connected to? This is just showing 0. Just 1 second. R6 is MISO, so that would be 0 volts. Okay, I'm happy with that. Let's start soldering the transistors on. Hopefully we don't kill it this time. What happens if they try to firmware upgrade? The thing is, EGS52 can't be firmware updated. By a workshop at least. It requires you doing certain crap to it in a tuning shop. But for instance, what I mean by it can't be upgraded is, I mean, EGS52 can't be updated by the dealer over CAN. Like their engine ECUs can. I mean, you can update it, but it just requires you fiddling around putting solder joints on the CPU and basically putting it into bootloader mode. Because I've tried it, and it basically states that firmware upload and download is unsupported in Keyword Protocol 2000, which is really strange. And if you go to various websites where they have CFF files, which are flash files for Daimler, I can't find any for EGS52. Which again reinforces that idea that they can't update it. Alright, let's test with that one in. .2 volts. Good. Let's continue with the next one. .2 volts. Next one. 3.2, next one. .2, last one. .2. Okay, so this is all good. Let's clean up. Actually, let's do one more round with some flux, just to clean up all the joints on the resistors, especially because they're really messy. I mean, I know Ian, I said I'm not OCD about resistor placement, but solder joints, yeah, I hate them. I found it funny, but I know some people would. Yikes, that's pretty tragic. I mean, yeah, I don't like working at these big institutional corporations. I mean, I had a phase where I applied to Daimler to see if I could get a job. Guess what? No, because I don't speak German. Especially for the engineering department. Like, their engineering department, everyone has to speak German for, apparently. But I'd much rather live this kind of life where I can work on improving older cars behind their back, where I can say, hey, so screw you for, you know, behaving the way you do, anti-consumer emissions cheating and stuff like this. And also just to prove a point in general, which is that older cars can be just as good as new cars, and you don't really need to buy a new one just because you want this really cool feature. Right, let's make sure that's all good now, that I've cleaned up all the joints. .2 volts, great, let's clean it up. Where'd me paintbrush go? There it is. I think this is coming on quite well now. We've just got one more line of these little dinky things to do. The shift logic level shifters to do, and then we're done. After some final testing of the board, so that tomorrow when my Tinsy comes we can actually verify that it works and doesn't blow up. Cool, that will do. Oh, I got flux all over my hand, that's not fun. Alright, we need 1, 2, 3, 4, 5, 6, 7, 8 resistors. 1, 2, 3, 4, 5, 6, 7, 8. By the way, in case you guys weren't here when I explained it, the reason for this cable here is the reason why it's because I killed my Tinsy by plugging it into this rail and then measuring the amperage across 12 volt and ground, and that seemed to just fry the Tinsy, because the 3.3 volt rail is assuming that you can stabilize the power, whereas the 5 volt rail you can give it some leniency, and the Tinsy will kind of manage it, and has over voltage protection there. Yeah, you're welcome, DSCH, to the car hacking scene. I mean, it's a fun place. Basically, just get to play with not man's best friend, that's a dog. You just get to play with fun electronics and stuff, and, improve stuff. My personal opinion is that I think it's shocking how bad OEMs are at security currently, and also with keeping their vehicles on the road. Like, Mercedes, right, used to be really good. Like, my 203 is such a good car, and then I've seen some of my friends with their newer C classes, and they're just honestly hot garbage. The build quality wise. And this is because car manufacturers are trying to cut costs. I mean, to be fair, Mercedes probably went from the best to near the worst, but sure, if Renault's the worst, I dread to think what their cars are like. Also, Ian, if you're still watching, I have a question for you. So, I know I don't have a protection diode against reverse polarity, but it seems that the linear voltage regulators do a good job of that as it is, right? And the TLE things here apparently have internal reverse voltage protection. So, I mean, I will add it, but my question to you is, do you reckon this is currently okay to put in a car for testing? Because I know, for instance, for the real deal, when it comes to putting in the car, I need another 5 volt power supply. So basically, the Tinsy will be powered by one, and then the sensors are powered by another one. Because I know the EGS52 module can trip a code to basically say that the power supply to the sensors is incorrect, and then can shut it off to stop other parts of the module from getting overloaded. Should be fine on the car. Cool, okay, well, I'll be driving around with this then. Someday, maybe. I mean, there's going to be a lot of days working in the car, just trying to get it to communicate over CAN with the rest of the vehicle. If you look at the schematic for the CAN protection tights. Okay, I'll look into that. You know what, this... Check the chip's automotive grade. Yes, the linear voltage regulators, TLEs, are just the CAN trees, and CEVA isn't. And obviously the TINC. The TINC is not automotive grade. Speaking of car electronic things, one thing I've never told you guys is, you know, I did that project where I basically made my car do Beat Saber stuff, whereby it would basically have a light show. Well, when I was developing that, I went for a drive one day after just doing it, right? And all of the lights on my car just turned off, and it was the middle of the night, right? And I got so confused as to why. And then for some reason when I turned the switch to the off position for the lighting and then turned it back to on again, the problem went away. And I was just like, okay. And I've never seen that problem happen again. I'm so confused as to whether that's a coincidence, but also what would cause that to happen. It was probably quite scary, because this was on a dark English... If you've seen some of the roads in England, 60 miles an hour, pitch black, no lighting. Okay, just before I put this all on, let's double check. Cool, so now we can put the final doodads in. 4 more. How the hell do you do that? How can a car lose its gearbox by connecting something to the OBD port at the wrong bus speed? Dead short on the cam, but why would that short it? You're connecting something at the wrong speed. Why would that short it? Thing is, Ian. Oh, 1 sec, sorry. Thing is, Ian. I've managed to short my CAN bus multiple times on my car, even with like a basic Arduino plugged in, and they're all fine. So I find it so strange. When I say short, I mean literally dead shorting the two terminals for CAN H and CAN L together, right? And everything behind it was all okay. So I have no clue what absolute garbage components he must have had on that. Okay, it's good news, guys. Finished assembling the PCB. It works perfectly. So, I'm gonna just get some solder wick now and just begin cleaning up some of the excess solder on some of these joints. Just to make the board look a lot prettier. Because I like pretty. I think pretty is good. And then we shall give it all a nice clean. Oh yes, that's one thing I said I need to do. Oh, hang on a minute, this wasn't even connected. Okay, please don't tell me it was that. If I put this together now and it now says like 12 volts, we're in trouble. Okay, good, it still says 3 volts, I'm happy. What else can be tidied up here? You can be tidied up. Actually, you know what? I've had an idea. Just to make this aesthetically pleasing, I'm going to run this wire around the back of the PCB. And where can I connect it to? I can connect it to the 5 volt. Oh, there we go. I moved this completely out of frame. My bad. I could technically connect it to the... Actually, let me turn my soldering iron off. We're done for soldering iron for now. I just need to do these ground connections, but I need to find a tip for that. I'll leave it there. We'll leave it there for now. So now let's clean up the PCB. Alcohol time. I wish I could just drink this stuff. So yeah, I'm actually very happy with how this has turned out today. Admittedly, we did have a bit of a scare earlier, but other than that, I think this couldn't have gone any better. I mean, obviously, yes, there will be a Rev 2 PCB assembly at some point, but for now we need to get the majority of the CAN work and all that stuff done before we can make our next revision, unless there's something fatally wrong with this one. But I will show you all the GitHub repository and stuff like that in a bit. Just let me finish tidying this up. Oh, that's a huge lump of salt flux I've just sucked up. So there's going to be a few days, by the way, which I'm going to be running it on my desk with solenoids connected to these pins here manually, and then if I'm happy with that, I'll then put the TCM connector on, and then it will go in the car. Because once that TCM connector goes on, it's basically impossible to do any modifications to the PCB. Do I have a toothpick? Yes, I do. Okay. Bit of burnt something, I don't know what that was. Alright, I think that will just about do. Apart from the ground joints, but I can do them tomorrow. Or another time, it doesn't have to be done on stream. I'm actually so proud of that. That looks so good. Here you go. Look at all this up close. Actually, let's see if I can get the camera to focus this close. Oh, maybe not. So we've got our voltage level, logic shifters, solenoid controls, CAN bus, danky wire thing, 3.3 volt, 5 volt, sensors, voltage sense, and our Tinsy, which will go in tomorrow. I think that's a really good attempt for the first PCB, to be fair. I mean, you also have to consider this is the first PCB I've ever made, or soldered for that matter. So I'm dead proud of this. Okay, I think it's time to show you guys the code. So, there's a lot going on as part of this. One sec. Config .h. So, the code will be on this repository that we bring up on my screen. There you go. This is the repository that we're using, Ultimate-Nag52. I think I've got it in the description currently, but yeah, you guys can check it out. Currently there's no working firmware for this, so it's all just brainstorming code. But now that I've got the PCB, we can actually start brainstorming and starting to actually write code to drive the transmission, which will be really exciting, but keep an eye on the repository. Anyway, if you guys don't have any more questions, that should be it for the stream tonight, and I'll update the thumbnail to the finished PCB so everyone can stare at it in awe. If you haven't already, follow me on Twitter, and yeah, hope you guys have a good week. Maybe this Friday, if I've got everything working by then, we can do a coding stream of this, and if you're very lucky, I might be in the car when we do this, because I'm working on a way to get my car battery, well, to power my car enough so that I can have the ignition on indefinitely without draining the battery. So once I've got that sorted, there's technically no reason why I can't just keep the ignition on like for hours upon end working on this. But anyway, thanks so much for tuning in, guys. I really appreciate it. Stay tuned for future updates. Goodbye.